Square roots are all about perfect squares. Perfect squares are any number times itself. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared 8 times 8 is 64, and so on. These are the numbers you can take the square root of and get a nice answer. So if I take the square root of 9, I get 3. The square root of 25 is 5. The square root of 64 is 8. Any of these numbers produces a nice whole number answer when you take the square root. But a lot of numbers don't. So if I said the square root of 20, there's no number times itself as 20. You might in your brain think 10, but wait a sec, 10 plus 10 is 20. 10 times 10 is not 20. There's no whole number answer for the square root of 20. So what we do is we simplify them, we break them down using perfect squares. So what I'm telling you is you have to go from this list. This list is the key. Look for a number, the largest one possible that divides evenly into 20. And you'll notice the first one, 4, divides into 20. So I'll rewrite 20 is 4 times 5. I can take the square root of 4. When you take the square root of 4, it goes out front. It goes out as a 2. So it goes right in front of the root. 2 square root of 5. So you can say 2 root 5, 2 radical 5, 2 root 5. All are correct. And there is times between the 2 and that root. The square root of 27. 27, look at the perfect square list. The largest perfect square that divides evenly into 27, it's the second one on the list, is 9. So rewrite 27 as 9 times 3. And just like the last example, I can take the square root of 9. The square root of 9 is 3. That 3 goes out in front of the root. And left underneath is this 3, which I couldn't take the square root of. So 3 root 3 or 3 radical 3 is the answer. How about the square root of 32? Now, this can get tougher because it can be harder to find that perfect square. When you look at 32, the first number you might think of is 4 because 4 is on the list, and you might write it as 4 times 8. But wait a sec. You can look and tell that 4 isn't the biggest perfect square because 8 still has a 4 in it. So what I'm telling you is if you take a perfect square out and your other factor still has a perfect square in it, then there's a bigger perfect square. So the biggest perfect square is these two perfect squares multiplied together. In fact, if you multiply any two perfect squares together, you get another perfect square. 4 times 4 is 16. 16 is the biggest perfect square in 32. It's 16 times 2. And just like the last couple of examples, I can take the square root of 16. It's 4. That 4 goes out in front of the root. Left underneath the root is the 2. So 4 root 2 is my answer. How about the square root of 40? Square root of 40. Largest perfect square in 40 is the first one on the list. It's 4 times 10. I can take the square root of 4. It's 2. Left underneath the root is the 10. I can't take the square root of 10. 2 root 10, which means 2 times root 10. How about the square root of 50? Square root of 50 is 25 times 2. The biggest perfect square is 25. I can take the square root of 25. It's 5. Left underneath the radical is a 2. 5 root 2. The larger your number is, the harder it is to find that perfect square. For example, if I said the square root of 108, that's harder to find the answer to. Harder to find the perfect square. But there are some tricks you can use. In fact, you can make a table if you have a graphing calculator, or there's a link on my website for a factor table. You can do it that way. We did that when we were factoring, you might remember. But there are also some websites that can help you find factors. I just did a search for factoring calculators, and I found one at calculatorsoup.com. I'll put a link on the calendar and on the wall map page. You can punch in the number that you're looking for and look down this list. So if you punch in 108, it gives you the factors of 108. But remember, that has to be a perfect square. So you have to take these numbers and go look on this list for the largest one that divides into 108. And you'll notice that right here that 36 divides into 108, and 36 is on our list of factors. So I can rewrite 36 or 108 as 36 times 3, and I can take the square root of 36. Square root of 36 is 6, left underneath the root is 3. Square root of 320. So I went to calculatorsoup.com and the factoring calculator. I punched in 320 and I'm looking down the list for the largest perfect square, and it's right there, 64. 64 times 5 is 320. So the square root of 64 times 5 is 8 root 5. Square root of 64 is 8. It goes out front. One last example. The square root of 567. So that's a tough one. And you can go to a factoring table again, or go to calculatorsoup.com and start looking down the list. But you can also just trial and error. Just start dividing things out and see what happens. It helps if you know some tricks here. There's a rule that says if you add up the digits, 5 plus 6 plus 7, so that's 18. If you add up the digits and 9 divides the sum, notice that 9 divides into 18, divides into 18 twice, that 9 will divide that number. 9 will divide evenly into 567. So that might be the first thing you try. I divided 567 by 9 and I got 63. So 567 is 9 times 63. Well, that we're on the right track, except here's the problem. Look at the number 63. There's still a perfect square in 63. Notice how if you add 6 plus 3 you get 9, and 9 divides into 9, just like I did below right here. 9 times 7 is 63. In other words, since 63 has another perfect square in it, there's a bigger perfect square in 567. In fact, the biggest perfect square is 9 times 9. So I'm going to write this as 81 times, and 567 divided by 81 is 7. It's 81 times 7. Square root of 81 is 9. That goes out front. Left underneath is the root 7.